My name is M. Sujata, working as Physics JL in DSWRS and JSH Vemla, Suryapet. So today we are going to discuss the small topic, the speed of the transverse wave. So before going for that, we'll go for the details about the transverse wave. So in the transverse wave, so then what is, first of all, what is a wave? What is a wave means? Wave is produced by the vibration of the particles of the medium through which it passes. For example, when the bell is ringing, the particles around the bell will get disturbed. So that disturbance will travel from one point to other point. Means the energy will transfer from one point to other point. So what is happening here means the disturbance by which energy will transfer from one point to other point through vibration of the particles without actual momentum of the particles. Means here what is we are saying means this particle won't move from here to here. It will get disturbed. Likewise, the other particles also get disturbed. So that is the formation of the wave. Okay, now here how many types of wave means based on the requirement of the medium, there will be the two types of waves. What are the waves means? The mechanical waves and the non-mechanical waves. The mechanical waves means the waves which require the medium is called the mechanical waves. So the medium may be solids, liquids and gases. But these waves won't travel to the vacuum. So the examples of the mechanical waves are sound waves. So what is a non-mechanical wave means? The wave which does not require the medium is the non-mechanical wave. They can travel through the vacuum. So examples, the electromagnetic waves, light waves, radio waves, these are all the non-mechanical waves. Again, in the mechanical waves, based on the direction of the particles and the propagation, we have divided into two types. What are those means? Longitudinal waves and the transverse waves. So what is a longitudinal wave means? So in the longitudinal waves, the particles disturbance will be in the direction parallel to the propagation of the wave. Means there will be some more density and less density, like these will happens alternatively. Means the more density is called as the compression, the less density is called as the rarefactions. So this compression and rarefactions will forms continuously and alternatively. So the distance between the consecutive compressions or the consecutive rarefactions is called as the wavelength. Again, one more topic is the transverse wave. So what is the transverse wave means? See here, in the transverse wave, the vibration of the particles is up and down, means perpendicular to the equilibrium position. So sometimes it will be up and sometimes it will be low. So the highest peak of the disturbance is called as a crest and the lowest peak of the disturbance is called as a throw. Again, these crests and throws form alternatively. The distance, the total distance between the two successive crests or the two consecutive throws is called as a wavelength. So now here in this type of transverse wave, we can calculate the speed. So the speed of the mechanical wave, is totally depends on the restoring force and also the inertial properties. So restoring force and the inertial properties. So if we can take the string, so when we take the string, the transverse wave in the string, the restoring force is nothing but is the tension. So tension is nothing but the restoring force, means its dimensional formula is so ml t power minus 2, and the inertial property is the linear density. So it is the linear density is the inertial property, means let m is the mass of the string and here it is a mass of the string, and if L is the length of the string, if it is length of the string, then linear density nu is equal to m by L. So m by L means that units are kg per meter. So kg per meter means that is m by L, that is equal to m into L power minus 1. If you can take the tension here, whatever the tension T, this T by equal to, here t is ml t power minus 2 by ml power minus 1. So here will get cancelled. This L power minus 1 will come up, means that will become L square t power minus 2. That is equal to L t power minus 1 whole square. This L t power minus 1 is nothing but the velocity. So t by nu is equal to velocity square. So now here velocity v is equal to under root of t by nu. So by using this formula, we can calculate the speed of the transverse wave. So this is the way how we can calculate the speed of the transverse wave.